Most of what you're going to be asked to do for Chapter 9 is to complete reaction equations like these. So these couple of slides here, little pop quizzes, are kind of a preview of what you'll see in the homework, and also certainly what you will therefore see on the test. So it's a matter of keeping these reactions straight when you're doing an addition reaction, knowing which atoms end up where, and in the case of that very first one, knowing that it's not an addition reaction at all, it's that acetylide ion reaction. So on the next slide, you've got the answer key to these. So if you haven't looked at those yet, you can pause this and see if you can come up with the correct structures for the products for these. And as usual, you don't necessarily have to draw out a balanced equation for these. I'm really interested in the fate of the organic compound as opposed to knowing what happens to the non-organic parts of it. And this is the next slide here with the answers magically appearing. That first one corresponds to removal of a terminal hydrogen. So it doesn't have to happen for ethyne itself. This is propyne, as long as you have, again, a terminal alkyne where the carbon-carbon triple bonds at the end of the chain, then you can get this to happen. And typically you would perhaps take that first product and react it with an alkyl halide, although that's not dealt with on this particular question. The rest of these are addition reactions, and again, knowing that the descriptions here have to do with how these hydrogens add. If there's a big 2 in front of the H2, you assume there's enough hydrogen to add 4 atoms of it, turning the 2-butyne here into butane. Otherwise, you have to distinguish whether you get cis or trans, so those are both of the recipes for that. And here are some examples using chlorine to show how it can be incorporated into molecules that start off with carbon-carbon triple bonds. The bromine versions are also common and work the same way. So knowing how Markovnikov's rule works for these first two so that you know which carbon gets the hydrogen, which carbon gets the chlorine. And then finally at the bottom, you're only adding one equivalent of Cl2, which means you're going to end up with a double bond, and you have to draw your product to indicate the correct cis-trans isomer situation for that chlorine. And as the last slide here shows, you only get trans for that dichloro product. And for the first two, you get, again, the Markovnikov addition, in which you are adding the hydrogens to the carbon that already has more of the hydrogens. So again, there's more practice of this kind of stuff among the worksheets, as well as assigned problems at the end of Chapter 9.